Hi, welcome back, everybody. Um, it's time for Tech Talk, and for this week, we are going to be discussing 3D printing, the technology, where it started, where it is now, and our experiences with it. So I'm joined by a few student mentors today. Let's introduce everyone. So to get started, let's have Zekram. You can say hi.
Hello, everybody.
Mentor Encore.
Hello, everyone.
And lastly, Mentor Matt.
Hello.
So this is a personal favorite subject of mine. My background isn't in computer science like many of us at kidOYO. Mine's actually mechanical engineering, so that goes hand in hand with 3D printing. To start out, I know I have, at this point, a few 3D printers. Does anyone else have a 3D printer?
Yes, I have a FDM and an SLA 3D printer.
And we're going to be talking about and discussing what those two terms mean, FDM and SLA. But continuing on, how about you, Mentor Encore? Do you have one?
I have a Prusa Mini 3D printer.
All right. And correct me if I'm wrong, Matt, you do not have one, but you've used them in school, correct?
Yeah.
Nice. So it's pretty awesome. We go around, we work with a lot of school districts. That's how many people may know us, though that's actually not how we got our start. But I go around into schools and I see pretty much every school has at least a 3D printer, if not multiple. And that's crazy to me because in college, we only just got 2 3D printers for the whole school. And that's 20,000 people. We had like 2 for the entire school, which was kind of wild because that is definitely like, I'm obviously a bit older, but that's definitely a bit behind the times. And I see high schools now with a bunch of 3D printers in mechanical engineering. I didn't even have one, but that kind of also talks to how rapidly the technology has been improving. So does anyone know when 3D printing really got started?
Well, I know that there was a set of patents that expired. It was either in the 2000s, I think, in the early 2000s, and that was when like consumer 3D printing took off.
Yeah, so 3D printing, although it may seem, for some people it seems, kind of old, but only a few years old. For others, it seems really new. It is actually kind of an old technology, not super old, not like archaic, but it's been around longer than you think. It's been around longer than I've been around. So I wanted to start off this discussion kind of with like a timeline of 3D printing. There's a couple out there, but I found one that looks really good on the website for the American Society of Mechanical Engineers. And I'm just going to push this right here. So if we scroll down, we can see that 3D printing really started in the 80s. You have some early work done here in 1980, just using UV light to harden material, and then specifically selecting which where you harden the material is where we start off in 1983 with stereolithography, and that is SLA. A stands for apparatus, but most people will refer to this technology as SLA or stereolithography if they want to be a little bit wordy with it. So SLA was one of the first 3D printing methods, the first 3D printing method. It's not currently the most popular though. And I think, correct me if I'm wrong, Andrew, but you wanted to talk a little bit about that, I guess a little later on after you kind of get through the history, right?
Yeah, I feel like it's a little bit misunderstood and a little bit intimidating for people just taking a quick glance at it, but it isn't as hard as it is displayed as.
Yeah, and like I agree with you, but I'll admit I don't have one, so I'm definitely interested to hear what you have to say about that. If we just continue on with this history a little bit, things kind of go a little bit slowly, just improving on SLA, and there are patents that are issued to these companies. And then in 1988, a company called 3D Systems created the SLA1, which was kind of like, this is a well-known company, this is a well-known printer, and just to show you what that looks like back then, that's this right here. It came with its own like whole computer here, and that's because this wasn't meant to be something used at home. This is meant to be on the factory floor, and if you've ever been in a lab or a factory, there are probably going to be machines, whatever they are. It could be 3D printers, it could be CNC machines, and they're going to be set up in a room in a layout, and there's going to be computers next to it so that the tech can work and operate that printer. And this is how that one kind of iconic 3D printer got started, or how it looked when the technology started. Then we come into 1989, where we get the first FDM printer, and that's what everyone who's familiar with 3D printing, that's what you think of. And that was the other 3D printing technology that Mentor Andrew had referred to, and FDM stands for Fused Deposition Modeling. Essentially, you melt plastic and push it out. So that's pretty much all the 3D printers people have, the MakerBots, the Prusa i3s, all these common 3D printers that you're used to seeing are FDM. Now, I'm going to kind of go through some of this history a little quick now. So you have a couple of other 3D printing technologies pop up. You have laser additive manufacturing, bioprinting, which is we'll talk about a little bit too. That's very interesting. And then we come up to 2005, which is the RepRap design. So RepRap was this concept of 3D printers printing 3D printers. And although it doesn't really take off here, this sets the groundwork for things to take off in just a few years. So I want you to remember this date here, 1989. There are patents issued for this technology. So in the United States, there's several types of patents. This one was a utility patent, and utility patents are good for 20 years. So fast forward 20 years, that's 2009. We're going to see something happen. 2008, we see the Darwin RepRap 3D printer. Shapeways, which is a website that you may be familiar with, launches and starts offering itself as a 3D printing service. And then 2009 happens. The FDM patent goes away. That means people can now start selling products using this technology. And from here on, you see a couple of things happen each year. You see Micro, a computer 3D printing brand, comes up with PLA and ABS materials. Kickstarter funds the first 3D printer project on the platform. MakerBot comes around. Thingiverse comes around. And I have to imagine these technologies were like waiting for that patent to drop to just start up. They were already working on things, I have to assume. And from there, things kind of rocket forward. You have all these different companies making their designs. You have DLP come through, which is kind of like stereolithography, but those patents drop out as well. They're a little bit harder to deal with, but these printers become ready for the consumer market for you to have at home. Stratasys, a big company, acquires MakerBot, and it kind of just accelerates from here. And every year you see different 3D printers come through. So Andrew, when did you get your first 3D printer?
Oh, I don't exactly remember. It was probably like, I want to say it was around the same like 2015 time. I think I got it the year before I built my computer. So right around 2015, I believe.
All right. And Ankur, when did you get yours?
I got mine last year, so recently.
Last year. And it's the i3 that you have, I'm guessing? Yeah. Or MK3, I forget what it's MK3, right?
Yeah, I think it's something like that.
And then, Matt, do you know what kind of printers you use in school?
After what you guys just discussed, or what you just said, I'm pretty sure it's like the plastic, pushing out the plastic, that one, but I'm not sure what's the brand.
Oh, you don't? Okay. So yeah, I think I got my first 3D printer around the same time as Andrew, or I should say, my first functional 3D printer. So I'm gonna get to that in just a second, but I actually did get a new 3D printer just the other day. So the first 3D printer that I had that worked cost $2,000. And I wanted to shell out to get something that I wanted it to work every single time. I had already been burned by trying to cut corners and spend not so much money. It's going all in. That's not the case today. I bought a new 3D printer that cost $180 and prints really well. And I thought what might be kind of cool while we're doing this is if I actually kind of just start up a print while we continue this conversation. Does that sound good to everyone?
Yeah.
All right. I'm gonna see what I can do here. So the printer I got was called the Elegoo Neptune 2, and I don't have such sturdy camera setup right now, so I'm going to try to just show everyone what I'm working with. This is going to be in the stream. It may not show up in our chat, but I'm going to just like, when I first started 3D printing, I just had a little LCD screen with a wheel. Andrew, you might be familiar. This printer comes with a touchscreen. It's really easy to use. I'm trying not to get too far away from the microphone while setting this up.
Yeah, it's interesting that you say that, how like a little LCD screen with a wheel. My the maker, or I have a Lulzbot Mini, the original Lulzbot Mini, and it doesn't even have an LCD screen on it. It's entirely controlled through a computer. But now, like you're saying, you bought a basically $180 3D printer that probably prints as good or better than your first printer, and that's sort of the same situation for me, where I'm looking at printers that are much cheaper that are printing the same quality or better.
Yeah, I mean, there's trade-offs for having a printer this cheap, and we'll talk about them. But the trade-offs, like I don't think I can say anything other than they're worth it. I've printed just a few things with this, and I'm using some like ancient filament that's probably super has a ton of moisture in it and everything like that, but it prints fantastic. And I'm gonna start something up hopefully in a minute, so we can just kind of watch that as we continue talking.
And I think one of the keys to though is that it doesn't have to be perfect at that price point, because it's such a good intro price point. Like 3D printing used to be like a pretty big investment not even 6 years ago. Now it's something that like a kid can work at their local like deli or restaurant for a few weeks and be able to afford it.
Yeah, even a few days maybe. It is at that level. And now I'm at the point where I kind of want to see if I can revive my first 3D printer that like printed once, I think, and never got a successful print out of again. I want to revive it with some of the new parts, because the parts are really good too. So I'll get this print started, and then we'll continue our conversation. I do want to just point out this LCD screen, like this printer, most don't do this. I think it's just this model because they have some custom firmware and everything like that. It actually gives you, let me see if I can move my camera here. It gives you, I don't know if you can see that. It gives you a representation, a 3D representation of the model you're going to print. Just it saves a picture file with the STL file, and so now you're not like trying to guess what you named a file. It's just you get to see it right there, which is really cool.
It's interesting because that feature is actually pretty standard for SLA. So when you said the name Elegoo has, I believe they were primarily for a while an SLA printer company. So like the SLA printer I have now does the same thing, but for FDM that's kind of unheard of.
Yeah, it is, and I wonder if it's just because they have their custom firmware and it was easy for them to add. So I'm going to go ahead and print this just by doing that. It says confirm. And then it's going to start loading up the G-code and start going. I'm going to change the position of this because you can't see the print bed. So I'm going to bring that back in just a second. Try to position. I think I just have a top-down view I can afford with how I can mount this camera. But yeah, I wanted to talk about kind of where I started with my printer. So I'll get that camera adjusted, and we'll bring that back in just a second when it starts up. Yeah, it's going right now. So this was my first 3D printer. It was called a Solid Doodle Press. This is back in like 2014, I want to say. At the time, there were some new 3D printers coming out all the time, like a few every year. It was hard to decide what you wanted. They all kind of are DIY, and then this one came around. So this 3D printer was a little over ambitious, but certainly very, very cool in what it wanted to do. So I'm just going to zoom out of this picture here. And if we take some other looks at it, all of it, like this is first of all enclosed. 3D printers weren't enclosed back then, and it looks really nice. I think my filament got caught, so I'm going to go ahead and turn that off. I don't think we're going to have the print today. I got the filament caught as I moved it over to my desk. Sorry about that. But yeah, this printer is very ambitious for what it did, and it didn't work as a result of that. But the idea was you had this nice desktop-looking thing that could be just like a regular paper printer, and it had a really cool way that it loaded the filament, where you just put it in top, and it loops through and goes through the middle. And it was a really clean design. It just never worked. And I think it's because of the hot end of why that was the case. But I've spent $600 on this. Very frustrated that it never worked despite all the work I put into it. And then I just cashed out for the lull spot. And it pretty much, up until the past year, worked every single time I wanted to print. I could turn it on, forget that I left it on, come back hours later, hit print, it prints right away. It's a great printer that I need to fix. But yeah, now I have this Elegoo printer that I'm going to hopefully use to repair that lull spot. What kind of things do you print on your printers? I'll start out with Andrew.
So lately I've been printing, I don't think I ever really used my FDM printer, the Lulzbot, for anything other than like functional things. So like when I first got it, I did some like test prints with like obviously their traditional like little octopus guy. I believe it's on screen now. And I quickly found out that that really wasn't my thing. Like the time spent to print out like a figurine or something really wasn't what I wanted to use it for. So I quickly sort of staged into printing like different gears and mechanical stuff and brackets. And I mainly use it for functional things now, like creating brackets for cable management and stuff like that.
Nice. Ankur, do you have any kind of designs that you usually use your printer for?
So we usually like used it for making like figurines and basically the opposite of what Zach was saying. So like figurines. We also did at one point like make mask holders. You know, those things that went in the back so you could hold up the ear things so they don't bother your ears. And yeah, that was a thing that we did for a while, but we stopped doing that since people stopped using them.
Yeah, I think I did that too at the beginning of the pandemic. I remember being a part of like different Slack communities, different different Zoom calls, and I was 3D printing masks for Stony Brook during the pandemic. So yeah, and I did that as well. Yeah, so there's a whole bunch of things. I personally am in the same boat as Andrew, where I'm doing functional prints. I don't care too much about figurines, though they're cool. They have their utility. I design things myself, and I usually design parts for different uses. I used to do project management. We had a part that broke, and to get that part in would have taken weeks. It would have taken that. It would have cost thousands of dollars. We would need to bring a tech in. I went to that job site, got the broken parts, designed something, printed it out, replaced it the very next day. And that's like, you know, going from weeks to thousands of dollars to, you know, $4 one day is just wild. But yeah, so you did mention that you do have that SLA printer, right, Andrew? Which printer do you have?
So I got a printer called the Photon Mono from Anycubic, and it's pretty much like one of their like mid-range models, but they had a sale, and comparing it to the FDM printer in terms of price, it was much cheaper from my like first FDM printer, and to the point where like I was like, wow, this is all it costs. And the difference between sort of FDM and SLA is really comes down to quality and also strength. So you'll see that like stuff that you print on SLA will have amazing, fantastic quality, and that you won't be able to see print lines, stuff like that. But in turn, you give up a little bit of strength depending on how you print.
Yeah, and that's largely why I went with an FDM printer myself. I cared about functional parts. Some of these need to be strong. That one that I printed for that job site needs to be very strong. It broke for a reason, so and it didn't break with the part that I put in. That's not something you could do with resin printers or SLA printers, and the materials they're coming up with are increasing in quality, but to my knowledge, FDM printers are still much stronger.
Yeah, from what I've heard, even the most like expensive, like tough resin is what they call like resin meant to be used in a tough application, is only as strong as PLA. So which
is like just about the weakest.
Yeah.
Yeah, so just about the weakest, not actually the weakest. But I guess that actually brings up the topic of materials. So with resin, there are a variety of materials. I don't know if you're too familiar with them. Do you know what kind of materials you would print with resin?
So, well, obviously it's a UV resin.
Yeah.
So there are a bunch of different formulas. Most of them are pretty tightly controlled in like how much you can find out about them, because obviously it's a competition. Just like you won't be able to find like alloy, like alloys that are used in FDM. But I know that generally it divides into like your tough resins, your resins designed to be used for like more enduring applications like gears and brackets and stuff. And then you've got like your middle of the road, just regular resins. And then you have like all natural resins that use like natural oils and are biodegradable, stuff like that.
Yeah, and what's actually really cool with this technology as well is they now also have some medical purposes. So I know they have dental resins, where you go to the dentist, now you need something made, you'd have to do a mold. That mold then goes to some other person who's going to make you a tooth, a post, all these variety of things, braces, mouth guard. And I think they are now using resins for those purposes. I think for teeth, but then you can also use it for mouth guards and a variety of other things, which is pretty cool. Yep.
So resin is used to make those molds. And this is what got me interested in like resin printing as a whole, is the idea that resin itself can't be used for like teeth or anything like that. It's actually like, it's not food safe. When cured, it's pretty like mundane and that you can touch it and you shouldn't be worried, but you don't want to like eat it. But it's very, very, very powerful for making like quick molds. So using like people make like dice molds out of it. You print out the dice that you want in resin, and then you use I'm blanking on silicone to make the mold of the dice, and then you fill it with a different resin that's stronger, like a regular plain old resin that isn't as weak. And the same thing works with dental. You make the teeth and then you mold and cast.
Nice. So there's a variety of different ways that we can use 3D printing for medical purposes. I did want to move the conversation along just a little bit, so I'm just going to recap what we can use with FDM printers. So FDM printers can use a variety of different materials. The first one that was used was ABS, really, and then PLA took its place as the most common filament used, and that's because PLA doesn't require a heated bed, it doesn't require a heated build chamber. ABS contracts a lot as it cools, and so it peels off the bed, it warps, it's not very good, but PLA is pretty stable across the temperature range. But in addition to that, we have several different filaments as well. So growing more in popularity is PETG. That stands for polyethylene terephthalate glycol. And that is a little less hard than PLA. It's stronger, so hardness and strength are different. PLA can shatter, but it won't deform. It'll just hit that point and shatter. PETG can deform a little bit, which actually helps it stand up to some use and abuse. The problem with it, it absorbs moisture, so you got to keep it dry. We're here on Long Island. I have hard times with PETG. I need to dry it in the oven, which be careful if you do that, but I need to dry it in the oven every time I use it. Going past that, there's HIPS, which is high impact polystyrene. Not too many people use that. It does come with the Sla printer. I think I know why, after struggling with PLA recently. It can be dissolved by some kind of solvent. It's a harsh one, so I wouldn't suggest it, but you can use that as a support material if you have a dual extruder 3D printer. And then you get into some of the specialty filaments. So there's various nylon filaments. Those are very strong. Nylon is the filament I used when I printed that one part for the construction site. There is polycarbonate. Very, very tough. You're probably familiar with polycarbonate sheets. You might call it Lexan. There is also flexible polyurethanes. So those are going to be the rubbery materials. Although those, you can make fun things with that. I've used it to make functional prints as well. I made a gasket for a sound enclosure because I had a pump that was really loud for a project that I had, and I wanted to make it quiet. And there are a few others out there that I'm blanking out on. Has anyone used some of these filaments before, or can think of any other specialty filaments?
So I've personally printed in ABS, PLA, nylon, and the the stuff that the Lulzbot comes with.
Hips.
Blanking on hips. Yep. I had a lot of trouble with nylon, mainly because I don't think I was properly calibrating the machine to print nylon. In terms of my like preference, I print mostly in ABS, but it does crack a lot because I don't have proper enclosure for it. And PLA generally gives me the best results because it's pretty much the simplest to print with.
Yeah. How about you, Ankur? Do you know what kind of filament you use?
Yeah, so I usually use PLA and PETG. That's basically it. Mostly PLA though.
Yeah, so PLA is the most common material people use. PETG's getting up there too. And the reason these two filaments are often printed also is because a lot of printers can't deal with any other kind of filament other than these two. And that's because they have hot ends. That's this right here. That they're not all metal. They have a piece of Teflon tubing. And that Teflon tubing can melt. It melts at a very high temperature, high enough that you can print with those two filaments, but not high enough that you can print with the others because those other filaments, their melting temperatures are a little too close to that of Teflon, or I guess something called the glass transition temperature, which is just when it kind of gets soft. The solution to that is an all metal hot end. That's the kind of printer that Andrew and I have. We have all metal hot ends. These can be used to print a wider range of materials, but they have their own cons as well. I have constant jamming issues in my all metal hot end with PLA, but I just tried it with hips the other day. No problem at all, printed just fine. I think that's why Lulzbot gives you hips when you buy your 3D printer, because they know there won't be any jamming problems because it's a higher temperature filament. The jamming is caused because it just gets too soft too quickly and then it gets stuck up in here. But yeah, so that is kind of a rundown on FDM printers. I do want to look at some of the other printers out there real quick, but I will just acknowledge this is also a direct drive printer. So direct drive means that the motor is right here on the printer, as opposed to a Bowden setup where the motor is off to the side and there's a guide tube that pushes the filament to here. It takes a lot of weight off of the printer. The only problem is usually Bowden extruders have that do not have an all metal hot end, so they can't deal with all filaments, and rubber filaments can't be pushed through that tube without bending and having kinks in them. So we're getting close to time here, so I do just want to finish off with the types of 3D printers available to us. So we've talked about SLA and FDM, but if we go down this list here, it just kind of shows you how these printers work. So Andrew, did you want to kind of explain this one a little bit with this diagram as we go through, since you have the SLA printer?
So my SLA printer personally is actually, it's not true SLA, it's what we call LCD, which basically means that there's an LCD screen at the bottom of a resin vat, and the build platform actually comes very, very close, like really, really close. I believe it's like 50 nanometers from the bottom of the resin vat, and the LCD lets through light in the shape of whatever a specific layer of that print looks like. And then the platform piston, like you see in the image there, pulls it off of the bottom. And it does that over and over again. So I believe this setup uses a laser, which is sort of true SLA, which basically the laser moves and is reflected to form the shape, sort of like FDM, just with light. And the resin, once it gets hit by UV light, solidifies. So that's how everything works there.
Yeah, so there's some SLA printers like this one, maybe you could call them true SLA printers that pull down into the vat to build the object, and then there's the other ones that you just discussed, which pull up, and those have some real benefits. I think those are probably the ones you see more often in that LCD screens. We have them; they're available, cheap, so you can build some cheap 3D printers with that. And instead of having to have the resin be the maximum height of your part be no more than the depth of the resin, you can have a relatively thin amount of resin and just pull out of that with these LCD type printers.
And one of the
yep,
one of the biggest benefits of using the LCD or also DLP, which we might get into in a second, I think I saw it on the list, is that you print a layer at a time. So if you have like 6 of the same object on your build plate, instead of with FDM where it has to physically lay down the plastic for every object, this literally cures an entire layer of resin in like about 2 seconds for some of the new like mono color, which basically uses a UV LCD with 1 layer rather than the typical like all colors LCDs. So that means that you can print multiple objects in the same amount of time, as long as they're the same height.
Yeah, so I mean, all 3D printers generally not all. There are some that don't, but for the most part, 3D printers are printing 1 layer at a time. The difference is this is almost instantaneously the whole layer at once, versus FDM where you're moving to all these spaces. If we go down, we have, just as you spoke about, we have DLP, which I guess you could argue your printer is kind of a mix between SLA and DLP. But what DLP is instead of using necessarily a laser, what it uses is essentially a projector. So I've seen people actually make their own DLP printers literally using a projector like you would project on the wall or in like a classroom. So similar technologies work a little bit differently, but all pretty cool nonetheless, and similar benefits. Low, high resolution, low layer height, etc. Then we get up to FDM. This is what we're familiar with. Don't want to spend too much time here. Now we're getting into some of the fancy 3D printing. This is stuff that you do not have at home almost ever. This is what people will have in actual factories. So SLS, selective layer sintering, essentially you are hitting a kind of powder material with a laser and solidifying it. You can do this with ceramics, glass. I saw one person who had giant solar panels in the desert and was creating sand castles by powering a laser to solidify the glass. Glass is melting temperature, I forget, it's like 2,000 degrees or something crazy like that. But this is a technology you can use. This one, essentially, you print, you lower the bed down, and then you have a roller just puts a fine layer of powder above, and then you hit it with that laser again. So that is selective layer sintering.
It should be noted that while it is currently only pretty much in factories, it's getting much cheaper. So I know there's actually a product designed for a household that's less than $10,000, which is still a lot. But the fact that it's that little amount of money, especially when this is like factory equipment that's like hundreds of thousands of dollars, is impressive.
Yeah, and just for comparison, once again, that 3D printer that I had, which certainly wasn't even the most expensive at the time, was $2,000 in 2015, and I just bought something that's printing with high resolution for essentially 1/10 the cost of that, $180. A couple of years later. So yeah, we might see this. I've seen people make these on like Instructables in a DIY format, but definitely a little bit more difficult to do at home. Takes a little bit more expertise. Similar to that is selective layer melting. Sintering and melting, slightly different processes, but the idea is the same. You're putting powder, solidifying it with a laser, and dropping it down by another layer. Sometimes you have a roller, sometimes you have a feeder. This can feed on top. You still need to flatten that out, I'm pretty sure. But this is how you're going to do ceramics, metals, and crazy stuff like that. Electron beam melting, kind of a similar idea, I think. I'm not too familiar with this. Some of these might just differ on essentially the same idea, but their patents are different enough that they're considered different technologies. This one's super weird. Laminating object manufacturing. Essentially, you have like a sheet that goes through, and it goes over something that's previously printed, and then a laser kind of burns the edge, and then it pulls the next bit of this belt over it, and then glues them together. And yeah, it's a pretty weird technology, to be honest. You can see a couple of videos of it happening. It's a little bit more niche, but certainly pretty cool. And I think this right here is the heater that glues them together or melts them together. I think I saw this to use to create like a 3D model of the human body for like, instruction purposes. And then we have binder jet technology. So this one I think is actually pretty cool. This actually isn't that foreign. If you have an inkjet printer at home, usually that's the color printers that take a long time and are kind of loud. This is kind of that. So inkjet printers, they like a paper printer, what they do is they heat up very rapidly the ink, and it actually kind of it vaporizes and explodes out of the printer head and hits the paper. Similarly, you can do that with some 3D printing materials, and you get super fine layer heights. They hit it with a UV. They often hit it with UV light to cure it. And why I think this is so cool is because some companies, HP for example, I believe, they have printers that can create injection molds. So injection molding is how you get pretty much any plastic part at scale. So if you are an engineer or you want to make your own product, you essentially will need to make a 3D printed mold. You will need to make an injection mold. Making injection molds is not that easy, and they cost a lot. A very cheap injection mold would be like $3,000, and then you have to get it manufactured. You usually ship it over to China, have a facility make it for you. And if you're just trying to get a new product off the ground, that's real tough. But with this technology, you could feasibly make your own mold, get to test it instead of making it out of metal, and then you can bring it to a local shop or even use your 3D printer, a regular Fdm printer, to injection mold with that injection mold you just made, and start getting some small batches of things made if you wanted to launch something on Kickstarter. This technology, for anybody who is looking to engineer their own products, very cool.
And that's an important limit of 3D printing. 3D printing does not scale, like, at all. So if something takes 10 hours to make one of them, if you need 1,000 of them, you're going to need either a lot of printers, which really isn't feasible even at their cheaper price, or a lot of time. That's why like injection molding is still the common method to create a lot of something.
Yeah, and if you're thinking like, well, wait a second, I know Lulzbot makes their 3D printers with 3D printers, or I know XYZ. A lot of printers are made out there with 3D printed parts, and they are done to scale, but it's only 3D printers. You don't see anything that as a consumer product that's 3D printed yet. You likely won't. But that doesn't mean 3D printers aren't being used for manufacturing. Right now they're being used for prototyping, but some of those technologies we just showed, SLS, SLA, SLS, SLM, those are being used for expensive metal parts that need to be produced rapidly, and they are actually replacing some manufacturing methods such as investment casting, which is also pretty labor and time intensive, and they're replacing it with 3D printed parts. And I've even seen people take regular at-home plastic 3D printed parts, they cast them in sand, remelt them, and then they get a completely solid part that has the same exact strength properties as a injection mold. There's still a lot of post-processing in there, and so they're not going to beat out injection molds. But for these small-scale runs, 3D printing is definitely making its mark. The last we have here is material jetting. I'm not too familiar with this. It is used by jewelers, and I have seen jewelers use 3D printing in order to make casts for various things and speed up their process. So lots of different ways that 3D printers are being used. One last one I wanted to talk about real quick was bioprinting. And that's because I studied biomedical engineering in school a bit, and we learned about this. It was a brand new technology, literally reading papers about it all the time, and it's extremely cool. So people have printed stuff like hearts and stuff like that work, but it's not generally what you see. Where you're probably first going to see this really getting popular is dental, which we talked about, skin grafts, because those are commonly needed and you can print them pretty quickly. And then you'll also see them in the forms of probably veins and vasculature, likely, as well as bone implants. So the way this technology works is you print usually some kind of structure made out of collagen, and then you inject different cells into that collagen, and then you incubate it, and it will look really, really rough at first, but as you incubate it, it actually becomes something like an ear or a nose, which is very cool. It speeds up some of these processes, for example, with a skin graft, much quicker. And this is an exciting new technology. I remember reading an article about a woman who needed a jaw replacement. They 3D printed a jaw out of titanium, and it's better than the existing technologies because when you want to print bone, you need to vary the density of it. Otherwise, you can actually harm the other bone around it. And with 3D printing, you can do that. With molding, you can't. So I'm really excited to see 3D printing take hold in the medical industry, and I think we're going to see some really cool things come out of it. And even Lulzbot, I think, has some bioprinting options for home, though I don't know how useful those are. But that's all the time we have for today. I've been sorry to keep Mentor Ben waiting. We're going to talk with him in just a moment regarding a project he's been working on. So thanks again to everyone who has joined me for this talk today. We'll have future ones. Stick around. We have the Game Jam and the Student Mentor Showcase coming up.